Hello everyone. Welcome to day 3 of AZ104 Microsoft Azure Administrator program. Today we are going to learn quite a lot of heavy things. We will start with network traffic management and then we will move on to hybrid identity, which is a combination of Active Directory and Azure Active Directory. And also we are going to end today with Azure Backup. Network traffic management. As per the Microsoft's flow, this is module 6. So far, we have learnt only the independent components like compute, which is the virtual machine scale sets, and virtual machines in availability set and availability zone. And then we learnt different types of storage, and there's no connection between these two. And then we also learnt about VNet and subnet and different types of security rules. What is the relation between all three? So here is where we are going to learn about the network traffic management. How can we do load balancing? How can we route via the traffic manager? We will learn all this in network traffic management. Let's get started. We are going to start with a sample architecture here. I have one VNet and one subnet, a very simple architecture. And I'm going to place three different virtual machines and they are going to be in availability zone 1, 2, and 3. So all the three virtual machines have the public IP, which is zone redundant as well. Now here's the question for you. If I send a lot of internet traffic to all three servers, will there be an equal load sharing? The answer is no. We cannot really promise any load balancing here. All the traffic will hit all the three servers, but there is no load balancing. Now, here is where we need some load balancers. We have different types of load balancers in Azure. We will check some of the PPTs and then we will come to the board once again. Let's try to understand Azure Load Balancer. What are all the load balancers which are there? There are two different and important load balancer, which is public load balancer and internal load balancer. Some people also calls it as internet load balancer and internal load balancer. And what are all the different types of options which are available and what do we need to take care while creating the load balancer? We will start with the concept of understanding public load balancer. So here exactly is our three virtual machines in availability zone. We are getting the internet traffic from outside world to the VNet, and in between the internet traffic and my virtual machines in availability zone, I'm going to place this wonderful component, which is the Azure Public Load Balancer, wherein if you see, this is called the front end and these three are called the back end. For example, if this is my public load balancer, anything which is internet facing is my front end and I can have my pool of servers and this is called back end pools. We also have internal load balancer. If you see any n-tier architecture, let's take a two-tier architecture here, wherein this is the web tier, which is internet facing, and this is the database tier, which is internal. Now, I can place my public load balancer here so that I can balance my web tier servers can balance the internet traffic. But in order to fetch the details from the SQL database, there should be a balance between the web tier and the data tier. That is none other than my internal load balancer. This internal load balancer is not internet facing. Here the front end is my web tier, my back end is my data tier. In order to create a load balancer, there are four components which are really very important. We will see what these four are. The first one is the front end configuration. In public load balancer, this is usually a public IP address which is given by Microsoft Azure. We don't have to give. But in internal load balancer, the previous pool which is above the data tier, which is our web tier, is our front end. And the second important component is the back end pools. Here, this is usually a set of servers, maybe VMs or virtual machine scale set. And the third one is the health probe. We have three different types of health probe here. We have TCP, we have HTTP, and HTTPS. So these two are in one category. TCP is in one category. Now, what is the difference between in these two categories? TCP always checks the virtual machine's ping if the ping is answered or not. But HTTP and HTTPS goes one step above and says, are you alive and are you in a position to take the load? For example, here is my load balancer and I do have three VMs connected to it. So it is really important for this load balancer to keep on checking the health probe of the backend. Otherwise, if one VM is not taking load, though the VM is up and running, it's not of much useful for us. And load balancer will not create another VM. Load balancer merely takes the load to itself and distribute it across the virtual machine. Let's say this is the first virtual machine, second and third. In TCP, the load balancer keeps on checking, are you alive, are you alive? But in HTTP and HTTPS, it checks, are you alive and can I give you the workload? And if the VM says yes, then there is an equal distribution. Now the recommended one is HTTP and the last one is the load balancing rules, wherein we don't have to configure anything but we need to completely check if everything is perfect or not. And also there is one point with the health probe. There is also a ping. We can control the time of the ping. How many seconds do we have to ping? That's the time. And also the attempt. How many times? So you can give 2, which means 5 seconds into 2. Load balancer continuously ping for 10 seconds. If there is no reply, the VM is considered as dead. Let's see a very practical example of the usage of the load balancer. We have 3 virtual machines in availability zones. All of them are in same VNet and one subnet under one resource group, and they are connected via availability zones. Here we can place our load balancer on top of my web tier. This is my web tier and this is my public load balancer. One of the main reason we are going to see public load balancer is it may be you may get a lot of exam questions related to public load balancer, and I will also show you a demo. We will create a public load balancer and make these 3 servers as the backend pool of this public load balancer. So this is the backend pool, and also we have a front end, and this is taken care by Microsoft Azure by giving a public IP address. The only thing that we need to take care is the health probe. So whatever you see in this page, I have the same setup ready. I have created 3 virtual machines, call it as LBVM1, LBVM2 and LBVM3. Let's go to portal and check the exact configuration and we will create a public load balancer. We are in portal and here are the 3 different virtual machines that I have created. All of them are in one resource group and in one location under the same VNet. All these virtual machines come with public IP address. When we put the public IP address, either we get the Apache page or the Windows IIS page, depends upon whichever operating system that we have chosen, and also depends upon what is the web server that we have enabled. Here I made a slight change in PowerShell that if we type in the public IP address of one virtual machine, instead of the default page, it gives hello world from the name of the virtual machine. And this is my first virtual machine's public IP. This is my second virtual machine's public IP. And the third one says hello world from LBVM3. Now, why have we done that? We are going to place it under a load balancer and make any one virtual machine down and see where exactly we are actually getting the web page from. So let's go ahead and create a public load balancer. Choose load balancers. Give it a name, my public load balancer. Internal or public? This is going to be a public load balancer. Basic or standard? Always choose standard. There is a difference. Basic comes with only virtual machine in the backend pool. Well, standard, if you choose standard, you can have a combination of virtual machines and virtual machine scale sets. Choose the public IP address. Yes, I'm going to create a new public IP. And availability zone, we have to make it zone redundant because these three virtual machines are in availability zone. I hope you remember the configuration that we have done while creating the virtual machine in availability zone. A quick recap. In the first page, you have to create the availability zone 1, 2, and 3 as per the VM name. And also in the third page under networking, you have to click on the public IP and make it zone redundant. Then only there will be a proper distribution across the zones within a region. We will wait for our public load balancer to be created. Our public load balancer is ready. So we have to take care of four different configurations. So these are the four front-end IP configuration. Well, this is taken care by Azure. Now this becomes my website instead of these three public IP address. So I don't need these three public IP address anymore. This is going to be my front end. Backend pool. Now we need to add the backend pool. We will give it as a name. We will choose the virtual network. I've put all of them in the same virtual network. And here are my virtual machines. There are no virtual machine scale sets. If you have chosen basic public load balancer, you wouldn't have got this particular option. Add the backend pool. And in this page, we must be a bit patient. Once this particular step is done, then only we can go for other step. Wherein so far we have been working simultaneously in the portal in multiple browser windows. Okay, in 30 seconds, the backend pool is added. It says three virtual machines. Now the health probe. We need to give a name for the health probe. And TCP, HTTP, and HTTPS. I'm going to choose HTTP so that my load balancer checks with the VM, are you alive and are you in a position to take the load? Interval 5 seconds is the minimum, and threshold you can either give 5 or 10, but that's too long, so I have given 2, which means within 10 seconds the load balancer takes a decision. Health probe is created. Now let's move on to load balancing rules. I'll give a name, and we don't really have to do anything here. Okay, so we are done with the configuration. Now let's go to the front end public IP. And this is going to be my front facing. Okay, so I'm getting the hello world from LBVM3. When I keep on refreshing, it changes. Now I get it from LBVM2. And after some time, it will be from LBVM1. Now this is from LBVM1. Now, why do we need this kind of configuration? Usually, there are some small startups who run their website in these type of three virtual machines. Whatever you see on screen, it's a ready-made configuration that you can give for small startups, wherein they can run their website with the help of load balancer. And during the weekend, they can take any one particular server down for maintenance. Let's say currently it is streaming from virtual machine 1. I'm going to take the virtual machine 1 down. I'm going to stop it for maintenance purpose. Why? Because this is an IS. So I need to take care of the operating system patch, the backup, the extension, and also any other patchwork which is needed for this particular server. Now, when I shut down this particular server, immediately it goes to the next available server. And if I have decided to shut down that server also, considering it as a low volume on a weekend, then my streaming happens from virtual machine 2. My streaming now happens from virtual machine 2. When you shut down the virtual machine 2, the website is inaccessible. But if the volume is very less, you can shut down any two virtual machines, do the maintenance work, and then make them up. Now, isn't it a very useful resource to run your website in just 3 or 4 virtual machines? Now, let's go back to the slide and see what are all the other options that I have for network traffic management. I do have something called application gateway. Here also I have the front end, I do have the back end pool, but in between I have something called listener. Now this comes with the application gateway, also comes with web application firewall, which is optional. Now what does this listener do? There are two different usage for it. You can run two different websites with one application gateway, or you can also do all the image routing to one particular pool of server, all the video routing to another particular pool of server. Application gateway is a layer 7 load balancer, wherein the public load balancer is a layer 4 load balancer. Let's go back to whiteboard to understand little more about this network traffic management. And here we are going to take a N-tier architecture, a very simple two-tier architecture. So here is the web tier, wherein you can put in virtual machine scale sets or VMs in availability zones. And this is your data tier. Here can be your public load balancer, and here can be your internal load balancer. This is a small ready-made setup for any of the startups. Let's assume that this company is growing and they have customers across the world. Will my load balancer handle that type of routing? That is a very big problem now, because the answer is no. Load balancer is not intelligent enough to do routing. Load balancer is also not a DNS resolver. So we need one person who is above the load balancer, and that is none other than our traffic manager. Azure Traffic Manager is a new service, a separate one from all the load balancers and application gateway. And in Traffic Manager, we have endpoints. So these three are considered as endpoints, endpoint 1, 2, and 3. And below the endpoints, we have the load balancers. And below the load balancer is our web tier, data tier, internal load balancer, and so on. So here is how exactly the entire architecture looks like. Traffic Manager, public load balancer, in between you have endpoint, and then your web tier. Traffic Manager is always front facing, and Traffic Manager does not take the load on its own. Unlike your load balancer, Traffic Manager does only the routing, but the advantage here is it is a DNS resolver. I've just cleared this page. So if I type in www.google.com and I typed in restaurants nearby me, I get wherever I'm based out of. I'm based out of Bangalore. So I get the restaurants which is particularly next to nearby my home, or probably within the next few kilometers radius. Let's assume a person from London is typing the same thing. Same keyword, same browser. Is it the same result that he or she is getting? No, that's because of Traffic Manager. We have multiple types of Traffic Manager available. We have understood the flow now. It's time to check what are all the different types of routing. We have priority routing, we have performance, geographic, weighted, multi-value, and subnet. What is priority routing? Let's go back to the previous slide. This is endpoint 1, 2, and 3. If endpoint 1 is down, immediately route it to 2. So it's only based on availability. If is the endpoint alive or not? The decision is taken only based on it. So that is your priority. Let's see the second one, performance. The query comes to the traffic manager. Here, 2 milliseconds latency, here 17 milliseconds latency, here 5 milliseconds latency. Quickly, based on the latency, the traffic manager gives the query to the endpoint. Here, the least one is 2 millisecond. Customer's query will be routed to this endpoint. As I said, traffic manager will not take the load on its own. Exactly opposite to the load balancer. Load balancer, the public load balancer takes the load to itself and does the load balancing, but no routing, no intelligence. So far we have seen both priority as well as performance. Priority is based on whether the endpoint is alive or not. Performance is based on which one can perform better. Now let's see the third one. This is the geographic routing. Let's take the same example that we have taken. Somebody is from London, somebody is from Germany, and I'm from India. We all have typed in the same keyword, best restaurants nearby me. For me, I get routed to this endpoint. A person from Germany will get routed to this endpoint, and also the person from London will get routed to a different endpoint. Now, this has the previous two traffic manager qualities as well, which is based on the priority and performance. So, most of the customers go for geographic routing because it is also a combination of priority, performance, along with geographic routing. No e-commerce, no search engines architecture is completed without the traffic manager. The fourth one is weighted. Let's say there are three different endpoints as per this picture. You want to distribute the load in percentage wise. For example, as of today, you're getting 33, 33, 33. That's how it's going on. But slowly you want to shut down this particular data center. In that case, instead of 33, align only 20 percentage of the volume to be routed to the first endpoint so that the remaining will be equally distributed across the two different endpoints. And then once you feel that 20% is working well, then move it to 10%, and then one day 0%, and then you can completely decommission this data center. Multi-value is for specific IPv4 and IPv6 endpoints. As of this day, while I'm recording this lecture, these two options were introduced only 2 weeks before. So far, I've personally never seen a customer who's using these two. Mostly people use geographic routing. Subnet. Let's say you are running two different websites in the same server, you can use subnet oriented traffic manager, wherein you can control the source IP range. We have seen multiple products for network traffic management. We started with the load balancer, wherein we have both public and private load balancer, and then we have also seen application gateway, which is load balancing on layer 7, and we have ended with the traffic manager, who's a DNS resolver but who's not a load balancer. Now we need a combination of any two or three. Public load balancer plus internal load balancer plus traffic manager is commonly used across many of the websites. Now, this is a very important slide. Based on this, you can take a decision what is suitable for your customer or for your organization.